The next section to cover is 12.3, 4, 5, and 6. It's going to use all those formulas on that reference sheet. So you want to keep your reference sheet out. We're going to use it frequently. And the nice part is at least you don't have to memorize these formulas. So again, here's your reference sheet. Okay. So we have area of a triangle, we haven't done that yet. Law of cosines, we haven't done that yet. But we're going to use the rest of these. Functions of the sum of two angles, functions of the difference of two angles, functions of a double angle, and functions of a half angle. So you need to just really remember that these are on this sheet and that you can use them. We'll also eventually do law of sines. Everything else is stuff we've already done. Okay. So first part is the sum and difference formulas. Basically the idea is we cannot say that the sine of 30 plus the sine of 60 equals the sine of 90. It's not true. But what you can do is use the formula given on that sheet to find an angle or a function such as sine of 15 by using the formula. Now I realize you can put it into your calculator and just find the sine of 15, and sometimes that's going to work perfectly fine. What's going to happen here is either you're going to get a multiple choice where you have to match up the formula to what you're given. Those you probably could still get away with using your calculator. But if you're showing your work, you're going to have to show all the steps, and you're also generally going to have to put it in simplest radical form, and so many times these are irrational numbers. So if you don't do all the work, you're not going to get any credit at all. Okay? But these are easy. So sine of 15. What the hardest part is thinking how we're going to find 15. Think about the angles that you know. You know that the sine of 30, you know 45, you know 60, you know 90. So you're just looking for a combination of those numbers, either adding or subtracting, that come up with 15. So if I want to find the sine of 15, I can use the fact that I know 45 and 30. Because if I subtract 45 and 30, I get 15. Okay. Then it's the easy part. We're going to the formula sheet. Sine of 45 minus 30. So difference, right? Difference of two angles. Sine of A minus B. 45 minus 30. Sine A cosine B minus cosine A sine B. Okay? So we're going to call the 45 the A, and we're going to call 30 the B. Okay, so looking at your reference sheet, the difference, sine A minus B, equals sine A, this is right off that sheet, so look at your sheet, sine A cosine B minus cosine A sine B. A is 45, so sine of 45, cosine B, B is 30, minus the cosine A, 45, times the sine of B, 30. So write out your triangles. If you haven't memorized them yet, do your basic triangles. Your 30, 60, 90, 1, 2, 3 square root. Or your 45, 45, 90, 1, 1 square root of 2. So the sine of 45, square root of 2 over 2. Cosine of 30, square root of 3 over 2. Cosine 45, square root of 2 over 2. Sine of 30, 1/2. Square root of 2 times square root of 3, square root of 6. 2 times 2, 4. Square root of 2 times 1, square root of 2. 2 times 2, 4. Written as one fraction, square root of 6 minus square root of 2 over 4. So, if you haven't memorized the sine, cosine, tangent, etc. of the angles, you should have your triangles memorized. You're looking for a way to find 15 with angles that you know. You're using the reference sheet. Take the formula right off the reference sheet. Make sure you write down the formula. That way if you make a typo transferring it from the reference sheet to here, you won't lose all your points. Fill in your A and your B. Evaluate and do the math and simplify. Pretty simple. Right, let's try another one. So this is the same idea. It's telling you to find x plus y, so your first thought should be using your reference sheet. But you're not given those 45s or those 30s that we know. We can still do this. So let's start with a formula. So cosine x plus y, which is the a plus b. Go to your reference sheet. Sum cosine a plus b, cosine a, cosine b, minus sine a, sine b, except we're using x and y. So it was cosine a, which is x, cosine b, which is y, minus sine x, sine y. So that's just your formula sheet. So we have some of it. We have the sine of x. We have the cosine of y. We need the cosine of x and the sine of y. So from here, you're going to make a triangle. Sine x equals 3/5. So go and make a right triangle. Call your angle x. Right? Because x. Sine is opposite over hypotenuse. So go to x. Sine is opposite over hypotenuse. So you're just filling it in. Opposite over hypotenuse. Now we're going to make a y triangle. Cosine of y is adjacent over hypotenuse. Adjacent over hypotenuse. Okay. Now you need to find the missing side. Right? We have a missing side here, and we have a missing side here. How are we going to find those? We're going to use Pythagorean theorem. A squared, 3 squared, plus, we'll just call it b, b squared equals 5 squared. 9 plus b squared equals 25. Subtract the 9, b squared equals 16. Take the square root, b equals 4. So this side is 4. Pause the video, do the same thing here. Figure out what the missing side is. You can call that a squared plus 5 squared equals 13 squared. So once you've done this, you should come up with 12 as this missing side. And these are your Pythagorean triples. You might have memorized those two, a 3, 4, 5, and a 5, 12, 13. So now we have our triangles, and we're going to use those to fill this in. Cosine x. Go to your x triangle. Cosine is adjacent over hypotenuse. Cosine of y. Y is, well, it's given, adjacent over hypotenuse. You can still go to your y triangle. Minus sine of x, given. Sine of y. Go to your y triangle. Sine is opposite over hypotenuse. When you're doing these for sine or cosine, the sum or difference, the denominators should match up. See how you have 5 and 13, multiply that out, you get 65. 5 and 13, multiply that out, you get 65. You should get the same thing. If you don't, something's wrong. You've made a mistake somewhere. 4 times 5, 20. 3 times 12, 36. 20 minus 36, so negative 16 over 65. Okay, so take what you're given, set up a triangle, find the missing side. Take the other thing that you're given, set up another triangle, find the missing side. Use your formula sheet, fill in the blanks, do the math. Fairly simple. Okay, next page. The only thing here is that we have to figure out positive and negative, so they're telling you which quadrant it's in, and that helps you figure out what's positive and what's negative. Both lie in quadrant 3. Okay, quadrant 3. Making my A triangle first. Cosine is adjacent over hypotenuse. So this is -2 over 3. Tangent, my B triangle. So make another one for your B triangle. Tangent is opposite over adjacent, so 2 over 3. So here's where it becomes important about the negatives, right? We go over negative and down negative to graph this point. So this is negative and this is negative. Okay? So you're going to do the same thing as we did in the last thing and find the missing side. So here they might not come out even. And remember that even though they're both 2 and 3, one, the hypotenuse is missing, one's a leg, so they're not going to turn out the same. So we have -2 squared plus b squared equals 3 squared. So we have 4 plus b squared equals 9. So b squared equals 5. So b equals the square root of 5. Remember, it's technically plus and minus, and then we have to think about where we are. Is this negative or is this positive in the third quadrant? So this is negative. So negative square root of 5. Here we have -2 squared plus -3 squared equals c squared. 4 plus 9 equals c squared. C squared equals 13. So c equals positive and negative square root of 13. Your hypotenuse is always positive because it's the distance from the origin to that point. So this is positive square root of 13. Okay. So we set up our triangles. Now we need to go to our formula sheet. Let's go look at your sheet. Sine of A minus B. Sine A cosine B minus cosine A sine B. Filling it in. Sine of A. Go to your A triangle. Sine, opposite over hypotenuse. So negative square root of 5 over 3. Cosine of B, adjacent over hypotenuse. -3 over square root of 13. Cosine A, adjacent over hypotenuse. -2 over 3. Sine of B, go to your B triangle. Sine is opposite over hypotenuse. So -2 over the square root of 13. Remember how I said before the denominators should match, and they do. So we get 3 square root of 13 on the bottom. We have negative square root of 5 times -3, so that's positive 3 square root 5 minus -2 times -2 is positive 4. So minus a positive 4. And nothing can be combined. Also here, you don't have to necessarily rationalize the denominator if it asks you to, if the directions are to, but otherwise you can leave it. So same idea. Create your triangles by what you're given. Write down your formula, plug in, simplify. Okay? Using the same thing, the sum and the difference formulas. Sometimes part of it will have an angle in it, such as 90. Okay? So we're going to leave this alone. We're going to use the sum and difference formula. So cosine A minus B. So A is 90, B is theta. So go to your formula sheet, cosine A minus B. You get cosine A, well A is 90, cosine B, which is theta, plus sine A is 90, sine B. B is theta. Now you have to go back and simplify. Cosine of 90 you can evaluate. Sine of 90 you can evaluate. So go back to your unit circle. 90 is right here. Over 0, up 1. Cosine goes with my x. Sine goes with my y. So the cosine of 90 is 0. Sine of 90 is 1. So all I did was evaluate the cosine of 90 and the sine of 90. Sine of 90 is 1, cosine of 90 is 0, everything else stayed the same. What is 0 times the cosine of theta? 0. 1 times sine theta, sine theta. So remember your last step, you always want to show both sides are equal, even though 0 plus something everybody knows is the something, you still want to show it. So again, these are all using the sum and difference, going back to the reference sheet, looking at the formulas, and evaluating. Last one. Use the difference formula for the cosine to find the cosine A minus B. A is pi over 6 and B is 4 pi over 3. So you can use it as pi over 6 and 4 pi over 3, or if you hate radians, we can change it to degrees. So if you want, take a minute and change those to degrees. I'm going to write down the formula. So cosine A minus B, cosine A, cosine B, plus sine A, sine B. Now if you want, you can change this to degrees. I'm going to leave it in radians, but if you want, change that to 30, and change this to 240. Alright, so cosine pi over 6, cosine 4 pi over 3, plus sine pi over 6, sine 4 pi over 3. So cosine of 30, square root of 3 over 2. Cosine of 4 pi over 3, reference angle of 60 in the third quadrant, so cosine is negative. Cosine of 60 is 1/2, so negative 1/2. Again, if you need to, draw the triangles, get that out, look at that. Sine of 30, 1/2. Sine of 4 pi over 3. Again, reference angle of 60 in the third quadrant. So sine is negative in the third quadrant. And sine of 60 is square root of 3 over 2. So we have negative square root of 3 over 4 plus negative square root of 3 over 4. So we have negative something plus the same something if we're combining like terms, right? We have one of these, so we have two of them. 2 square roots of 3 over 4. The 2 and the 4 can reduce to 1 and 2. And that's your answer. So this finishes up the 4 sections. Nope, I take that back. This finishes up the section on sum and difference. Okay, so you're using those formulas, setting up triangles, memorizing. You should already have these memorized or find a way to how to do them. So this was using just the sum and the difference. The next part deals with using the formula sheet, but we're going to use the double angle formulas. And then the final section is using the half angle formulas. Okay. So You've memorized the reciprocals, like cosine theta equals 1 over secant. The quotients identities, like tangent theta is sine over cosine. The Pythagorean identities, sine squared theta plus cosine squared theta equals 1. There's 2 more. So those you have to have memorized. You have to have your angles memorized, your 30, 60, 90 triangles, your 45, 45, 90 triangles, your unit circle, so you can do your 90s, your 180s. You can find if it's negative or positive depending on the quadrant. And now we've used the functions of the sum of 2 angles and the functions of the difference of 2 angles. So the only thing we have left are the double angles and the half angles. See you next time.